So here's a look at the finished product of this tutorial series. Remember, this tutorial series is not a tutorial on how to model a drone frame. It's a tutorial on how to use FreeCAD. So I'm sure for a lot of you that are already into drones, this frame will leave much to be desired, but it is my hope that with this tutorial series, you will be able to develop all the tools that you need to make any changes to this drone and make it custom the way you'd like it. First thing we're going to do is create our master sketch. I'm going to assume that you've already watched the Getting Started with FreeCAD tutorials that are available on my channel. So if I'm going a little too fast or something doesn't make sense, you might want to stop and take a look at those videos. So let's get started with our master sketch. First thing we'll do is create a new document and navigate to the Part Design Workbench. And we will start a new sketch and place it on the XY plane. Bird's eye view, top looking down, and we're going to lay out our flight controller first by selecting the square tool and putting a square centered on the origin, and we'll center it by selecting opposite vertices and select the origin last and use the symmetric constraint. Now we know our flight controller is a square, so we will select two opposite sides of the square, select the equals constraint, and we know our flight controller is 30 millimeters, so we will give a horizontal or vertical dimension, it doesn't matter which, of 30 millimeters. Next thing we're going to do is create the body of our drone, and we'll do that by selecting the square tool again, centering a rectangle about the origin by selecting opposite vertices, select the center origin, use the symmetric constraint, and we now will give dimensions to both of these sides. We'll use a vertical dimension of 100 millimeters. And we will use a horizontal constraint of 38 millimeters. These are completely up to you. You are the designer. If you want to make it longer or wider, that's up to you. These are just the dimensions I chose for us. Next, we'll cut out an area up here for our top plate to place the camera, and we'll do that by selecting the polyline tool. Make sure we get that constraint to fix onto that top horizontal line. We'll just make a quick cut out here. Now we can easily get rid of this area here by coming up and selecting our trim tool. It's got the perpendicular lines like a T with the dotted line coming out the top. If we select that and click right on that middle portion there, it'll trim it right out. And we can give both of these top edges an equals constraint. And we'll give them a dimension of 8 millimeters. And the last degree of freedom we have is the length here. And we'll go ahead and give that a vertical dimensional constraint of 20 millimeters. Now we can quickly lay out where the position of our arms will be, and we'll do that by selecting the line tool, starting a line right at the origin of our drawing and placing it up in the second quadrant. The next thing we'll do is put a circle on the tip of that line, coincident to the point on the tip, and we will dimension the diameter of that to be as big as we want our props to be on our drone. So if you're making a 3-inch drone or a 5-inch, I'm going to do this one as a 5-inch drone, but we're in millimeters. Here's a really cool feature. If you just press 5 and then IN, it's going to know that you want 5 inches, and it's going to give you a 5-inch diameter there. So that's pretty cool. So the next thing we'll do is place it. We can make it wide here, we can make it stretched here. As long as we don't cross over into one of these other coordinates, you know there won't be any interference with the other propellers from those arms. And we want to make sure that we don't come in too far here and interfere with our standoffs. So looks like something like that's good. I want to do a true X. So to do a true X, I will select this, the line for the arm, and then the top left vertice of our flight controller layout. and we're going to do a fix onto constraint there. And then I'm going to dimension the length of this arm. I want it somewhere around here, so let's see how long that is. We'll just select our length dimensioning tool, and it looks like that's 110.3, so let's make it 110. That seems to be a pretty common drone size. So now that we know the layout of our arm, we can see that there's not too much real estate here to provide mounting holes for the arm to the bottom plate. So let's go ahead and create some area here for us to create some mounting holes. We can select our polyline tool and just make sure we get those constraints on there. And we're going to first constrain this to the x-axis, and then we'll left click a couple of times to exit the tool. We'll select our endpoint and the vertical line of our bottom plate body, and we will use the fix onto constraint. Another thing I like to do is always make the arm perpendicular to the little area we're making here for the mounting holes. So we can click these two lines and use the perpendicular constraint. And another thing we can do is use the symmetric constraint to make sure the arm is always in the center. So we'll select the two endpoints of that line, we'll select our arm, and we'll use the symmetric constraint. And the last thing we have to do is give this dimension, or give this line here a dimension. So we'll use our line dimensioning tool, we'll select the line, and we'll give it a dimension of 15 millimeters. Now you can see we're fully constrained again. And we've got plenty of real estate here to make our holes for mounting our arm. So now I'm going to show you how to mirror these two lines across the x-axis to be added to the bottom part of our drawing. But before we do that, I want you to click over here on the left in your tasks panel. I want you to make sure the auto remove redundance is checked. So that's going to remove extra redundant constraints automatically, and it won't give you an error message. So now what we're going to do is click both of these lines, and then we're going to select the x-axis last because that's the line we're mirroring it across. Very important that you always choose the line of mirror, or the mirror axis, last. So then we'll come up here and we'll click the green arc, the white arc, and the little green line in the middle, and it's going to transfer that geometry, but it only transferred the dimensional constraint. We still have to add some of the other constraints here, and if we just kind of play with this line a little, we can see that it looks like we need to fix the length of this. We need to put this on this line, so we'll fix onto point with that point and the edge of our frame. And then we need to click these 2 points here and give them a coincident constraint. And then we need to dimension the length of this line. So we'll make these two lines equal. And then looks like the last point is to kind of position this point here. If we give these 2 points a vertical constraint, it'll lock them in place. It doesn't have to be a line to give a vertical constraint. You can give 2 points a vertical constraint. And when we do that, we are fully constrained again. The last thing we're going to do here is remove one of these dimensional constraints and add an equals constraint between these two lines. Do that because we want the drawing to be easy to modify later. So we'll select this dimension, we'll delete it, add a constraint here of equals between those two lines. And now if we come in and we edit this 15 millimeter dimension, see that both sides of the drawing are actually updated. Just a little note there, as a designer, you might want to add your constraints in a way that make the drawing easy to edit for later. Now let's lay out some holes to mount our arm to our frame. The way I'm going to do this is use the point and create a point on our arm. And then I'm going to fix it onto the vertical line of our frame edge with the fix onto constraint. And I'm going to use that as a center point for a line that we will lay out the holes on the endpoints. So I'll draw a new line here. And we first want to make this line perpendicular to our arm. So we'll use a perpendicular constraint for that. We also want it to be symmetric about the arm. So we'll select the two endpoints, select our arm line last, use the symmetric constraint. Then we want to fix it onto the point. We'll select the line, we'll select the point that we drew, and we'll fix it onto there. Last, we have to dimension the length of the line. So we will use our length constraint. And we're going to go ahead and make this 6 millimeters. Now the endpoints of these lines will be 3 millimeter holes, which will give a 3 millimeter gap between. Before we start this next step, I think you guys can see that our drawing is getting a little cluttered here. So to get rid of all of these dimensional constraints that keep getting in the way of selecting our geometry, we can click this little symbol here. It's the white and red circle and squares that look like they're in between parentheses. And when we click that, it'll send our dimensional constraints. It'll send all of our constraints to another virtual plane. So you can click to get them back, and you can click to send them. Now it's nice and clean for us to be able to keep working and selecting the different geometries without getting in the way. So to lay out these next holes for our standoffs, we're going to draw a couple of circles here. Once we get these circles located in space, we're going to mirror them over the x-axis. So the first thing we'll do is we'll make these two circles equal in size to each other with equals constraint. And then we will select the top one and the inside line here and make that tangent with the tangent constraint. And we will add that constraint to the circle, same circle, and the horizontal line at the top. And we're going to do the same thing with the outside edge. Now you can see that we have two identical circles. This one can still move in space, but this one is actually locked because of the three tangent constraints. So this circle, we're going to add a tangent constraint to the outside edge. And then we are going to locate it. You can go crazy trying to figure out what to locate these in reference to. So we're just going to kind of do something a little generic here and just make a distance constraint between these two, a vertical distance. And we're just going to do 18 millimeters. Now we are fully constrained again, but we need to get these circles to lay out the other half. So we will select both of them and then select the x-axis last. We'll use the mirror constraint up here we learned earlier. The green arc, the white arc with the green line in the middle. And now these have been mirrored, but they have no constraints. So let's click both of the circles and click one of the upper circles and give them an equals constraint. And then we will give all of these circles, we'll select the center points and give them all a vertical constraint. So, and then the last two that we have, I know, are the verticals here. So if we look, yep, they can still both move vertically. So what we're going to do here is we will select this circle, the center points, select our x-axis, and use the metric constraint. We will do the same thing for the outer circles, select the center point, and use the metric constraint. Oh. Center point, about to click the axis, and click the metric constraint. The last thing we have to do is add the holes to the arms for the motor mounts. Real quick before we do that, guys, though, if you've made it this far, please give my channel a like and subscribe if you are new. Also, let me know in the comments what you think you found most helpful through this part of the series. I really appreciate your feedback. It helps give me new content for my next videos. So to lay out the motor holes, I've looked up a motor online. You can usually find these schematics on the manufacturer website. Super easy to find. So looks like these two holes are 16 millimeters apart. These two holes are 19 millimeters apart. And that's actually really easy to lay out on the drone. So the first thing we'll do is we're going to draw two circles that are going to be coincident. The center points will be coincident with the end of our arm, the end point here on our arm. So when we create those two, we're going to give the first one, we'll dimension diameter to be 19 for the outer one and 16 for the inner one. And then we're going to draw some lines here. Try to draw them in an X pattern like this so you don't snag any of the horizontal or vertical automatic constraints. Let's use the polyline tool and we'll make kind of an X pattern here. It doesn't have to be perfectly collinear. We will select, now that we've drawn those, we'll select all three lines and we will add a parallel constraint right here. And then we will fix this line onto the center point of our circles by using the fix onto point constraint. And now we've got a circle here that can rotate. If you select one of these outer points, we can rotate it. And now we want to create another one of those. So let's do the same thing. We'll use the polyline tool, click on outer circle, inner circle, across the center, and inner circle, outer circle. And we'll select all three of those and we will make them parallel with the parallel constraint. And the last thing we'll do is we'll fix it onto point right here. So now we've got another line. The next thing we'll do is we will select the two inner lines and make them perpendicular to each other. And you can see we've got a rotating kind of layout for our holes. So the point to this is that, this arm is always, the motor wires are always going to come out at a 45-degree angle to where your holes are laid out. So what we will do is if we change the angle of this arm, we will be able to change the angle of this easily if we just select these two lines here and give that an angular constraint of 45 degrees. Now, if you ever change the angle of the arm here, you know that these motor mount holes will always be coming in the correct direction to line up your motor wires along your arm. So that's it for this tutorial. This is our fully completed master sketch. All we have to do is close out here. And you can see we've got this sketch now. In the next video, I will show you how to start making your solid parts.